So this question in hand says, an aeroplane has to go from a point A to another point B 500 kilometers away due 30 degrees east of north. A wind is blowing due north at a speed of 20 meters per second. The air speed of the plane is 150 meters per second. Find the direction in which the pilot should head the plane to reach the point B. Also find the time taken by the plane to go from A to B. So, as we look at this figure that we have drawn for the situation given, understand that the plane has to actually move along the line AB, which makes an angle of 30 degrees with the northward direction towards east. But since there is a wind blowing, the weather is not that calm. When the plane tries to move along AB, because of the wind speed, it will be shifted in its direction of motion. So, if we just try and look at the situation here, do we understand physically that the plane has to be steered in a direction which is somewhere here, somewhat like this, so that when to this the velocity of the wind is added up. Let's take it a little further up. So we assume that, let's say, the aeroplane moves in a direction which is like this. It is being steered in a direction like this. That means the pilot of the plane will try to move this plane in a direction which, let us say, makes an angle theta with the direction AB on the other side of AB. Then, because of the wind blowing, the airplane will actually be moving in a direction which will be then along AB. So, if we just try to show it vectorially, this is how it will look. I'll just try to get an accurate figure here. So, when we add to this the velocity of the wind, which is here, and this is, let's say, the velocity of the aeroplane with respect to the wind, which is when the wind is not blowing, which we also call as the air speed of the aeroplane. The air speed means the speed of the aeroplane when there is no wind, when the air is still. So, only if you have your aeroplane being steered in this direction, when you add to it the wind's effect, the two together will add up to give you the final velocity of the aeroplane, which will be along the line AB then. This is how we physically understand this. Mathematically also we can get the same relationship just by going back to the basic definition of relative velocity. We know that by definition, velocity of aeroplane with respect to the wind should be the velocity of the aeroplane minus the velocity of the wind. So, from here we can rearrange the terms here to get this equation. Velocity of aeroplane is equal to velocity of the aeroplane with respect to the wind when there is no wind blowing, and added to this the velocity of the wind VW. So, this is what we are getting here. When we add VW to VAW, we are getting the final velocity along the line AB where we want our aeroplane to move. Okay. So, what essentially we have to find out is the direction in which the pilot should head the plane to reach the point P. That means we are supposed to find out the direction of the vector VAW, the direction in which the planes should be steered. Now, there are various ways in which we can specify the direction of the aeroplane's velocity with respect to the wind. However, we shall see here that from this figure, we can identify a very quick way, a very easy way. It's a little tricky, but it's the shortest one to identify the direction of VAW. It is by specifying this angle theta that VAW makes with the direction AB. How do we do that? Once we know that the vector sum of VAW and VW, which I have drawn here also on the left side as two vectors, the vector sum of these two vectors is going to be along AB, the line AB. Do we understand that it also means that the vector sum of the same VW as well as VAW, when I add these two vectors together, they should have no component along the line perpendicular to AB, which will be a line somewhere over here. Yes, this we know from the basic understanding of vectors. We know that whenever a vector is in a certain direction, it will never have a component along a direction perpendicular to it, because if this is the perpendicular direction, the component of this vector along the perpendicular will be the magnitude of the vector times cos 90, and we know cos 90 is 0, right. So, if there is a vector which is along AB, that vector should not have any component along this direction that we have drawn here, which is exactly perpendicular to the direction AB. Now, when we check through this, it is the vectors VW and VAW which are together giving us the vector sum along AB. That means when we try to take up the components of VW and VAW in directions perpendicular to AB, those two components should exactly cancel out. How do we look at this? The component of VW in the direction perpendicular to AB will be this component. Just look at it. And since we know that this angle is 30 degrees here, we understand that this component of VW perpendicular will be VW sin 30. And on the other side, it is this VAW which, when I try to take its component along the perpendicular direction, it will be this component, which will come out to be VAW sin theta, where theta is the angle that VAW makes with the direction of AB. And now we are saying that the vector sum of these two components should be 0. That means these two components should exactly cancel out, so that there is no component of the sum of VW and VAW along this perpendicular line. So, we can directly write this equation that for VA to be along the direction AB, the components of VA along the perpendicular direction should be 0, which means VW into sin 30 should be equal to VAW into sin theta, and this will directly give us the value of theta, the angle that the velocity of the aeroplane will make with the velocity of aeroplane with respect to the wind will make with the direction AB. So, from here we can simply substitute the values and get sin theta is equal to VW sin 30 over VAW, and just by substituting the values, VW is 20, sin 30 will be 1 by 2, and VAW is given to be 150, the air speed of the aeroplane. So, when we solve this, we will get 1 by 15 as the value of sin theta, corresponding to which theta will be sin inverse of 1 by 15. So, you get the answer to your first part, the direction in which the pilot should head the plane. Now, in order to find out the time taken by the plane to go from A to B, we have to really find out the velocity of the aeroplane with which it moves along AB. Now, we know that if the aeroplane has to move along AB, this is the value of sin theta. So, can we just find out the net velocity of the aeroplane VA, which will be now along AB? So, for that we simply write velocity of aeroplane will be the component of the wind's velocity along the direction AB, which will now be VW cos 30 plus the component of VAW, the velocity of the aeroplane with respect to the wind in the direction of AB, which will be VAW cos theta. This will give us the velocity of the aeroplane. So, we can substitute the values here. VW is 20, cos 30 will be root 3 by 2 plus VAW is 150 into cos theta. We can find out once we know the value of sin theta. Yes, cos theta maybe I can write as in square root of 1 minus sin square theta. So, square root of 1 minus 1 by 15 whole squared. Solving this equation will get the value of VA, and after that all we need to do is, in order to find out the time that it takes to reach the position B from A, we need to divide the distance that it has to travel divided by the speed with which it is travelling, which in this case is given to be 500 kilometers divided by the speed VA that you just calculated over here. Just substitute it down here and solve it to get the value of time. Thank you.